Welcome to today's lecture, my dear students. In today's lecture, I am going to explain you about the geometric series. What is meant by the geometric series and what is the limit of this series? All this we will be discussing in today's lecture. So, what is the geometric series means what actually is? Suppose you have a series of the type A plus AR plus AR square plus AR cube and so on. And of course, this is an infinite series. How can we represent this in the summation form? It is summation A into R power n minus 1 and n is going to 1 to infinity. So this is what the infinite series, and in this one type of series is the geometric series. We will be discussing two types of the series. One is geometric series and the other is a power series. Okay, so what is A into R power n minus 1? That means when you put n is 1, you will get the first term. When n is 2, second term, like that. Now what is the observation here? When I multiply with R, I am getting the second term. When I multiply with R again, I am getting the third term. When I multiply the second term with R, getting the third term. Third term multiplying by R, I am getting the fourth term, like that. For example, let us have an example here. Let us say 1 plus, I am taking the series example only, 1 plus half plus 1 by 4 plus 1 over 8 plus 1 over 16 and so on. Now, in this series, this is an infinite series. How can we rewrite this in the form of summation? This is 1 over 2 the whole power n minus 1 as n goes from n to infinity. Okay, so it is 1 over n is 1, it is 1, and when n is 2, it is 1 by 2, when n is 3, it is 1 by 4, like that it is. So this is what the infinite series, and here it is a particular number with which you multiply, you are getting the next term. That means the common ratio is, this is what the quantity we call this as. The common ratio is the particular number with which you multiply, you will be getting the second term. So that is the common ratio here is 1 by 2, and here the common ratio is R here. So this is common ratio is 1 by 2. Now I'll give you one more example. Let us take the terms as 1 plus 2 plus 4 plus 8 plus 16 and so on. So how can I rewrite this one as summation n is equal to 1 to infinity 2 to the power of n minus 1. So this is what the geometric series also. Why? Because now the common ratio here is the particular number with which I multiply, I'll be getting the next number. That means 1 into 2, I'm getting 2. 2 into 2, I'm getting 4. 4 into 2, I'm getting 8. 8 into 2, I'm getting 16. So what do you mean by that? I'm multiplying with the 2 for the previous term to get the next term. So this is what called as the common ratio. So as I discussed in my first lecture, if you remember, my series, now this series, when I sum all the infinite terms, whether it goes to a particular number where we will be getting a threshold. That means what is the limit of this series when you add up all these? What is the limit of the series when you add up all this? This is what we have to find out. And the beauty here is, even though you add an infinite number of numbers, if you are able to get a finite number as the sum, then it is a convergent series. If you make the sum of all here when you add up all these infinite numbers, infinite terms of this series, if you are able to get the sum of all these elements, all these infinite number of elements is going to be a finite number, then which gives you the convergence, that means the limit is there and the limit is a finite limit, we say, and then the series is said to be convergent. And in this here also, if I add up all these infinite numbers, whatever infinite terms I have, and if the sum of all these infinite terms is giving me an infinite, suppose, then we say that it is a the limit is infinite, and hence it is a divergent series. Now you may think that since I am adding all the infinite number of terms, definitely the sum of the terms, infinite number of terms, gives you only infinite. Not like that. If you observe my first lecture on infinite series, you can understand what is the sum of all these infinite series. So by that example which I have explained you in the previous lecture, you can understand even if you add an infinite number of terms, we will be getting the limit as finite. So by using those concepts here, we can write one important result here, that the convergent and divergent series, the convergent and divergent series. So when we say that the geometric series is said to be convergent, means the summation a into r power n minus 1, n is from 1 to infinity. This is the geometric series, and it converges. This geometric series converges if your value, what is the first term, is a. Your first term is what here? A plus AR square and so on. With the common ratio, it is equal to R, correct? So, converges if this A over 1 minus R, the common ratio is R. A over 1 minus R is converges to this element, this number. The number is converges to this particular value. A by 1 minus R is the limit actually. If at all, if you say that this common ratio R is less than 1 and it diverges, that means the limit becomes infinity if your common ratio is greater than or equal to 1. So I'll just go through one previous lecture where I have to taken this one now. Sum of the infinite terms, when I have explained you in my previous lecture, in this example, you just go through this example, you can see the wonder here. When the sum of all the infinite terms, when you add, you are getting, it is not crossing 2. This is what I explained you in the previous lecture. Just go through that lecture, you will understand. So now coming to this point, that whenever I say that the common ratio has become less than 1, then it is a convergent series, and if it is more than or equal to 1, then it is the divergent series. So for solving this type of problems, I'll just take some of the few problems and for which it is convergent. Let us take an example. If I take the sum of the series, the infinite series, let us say my infinite series is sigma 3 to the power of n is there, suppose. How will we, and it starts from n is equal to 1 to infinity. So what is here? I can express this as 3 power 1 plus 3 square plus 3 cube and so on. It is very much clear that what is clear here? It is 3 plus 3 into 3 plus 3 into 3 into 3 and so on. So what is the common ratio here? The common ratio is 3. And is it greater than 0? Of course, greater than. Is it greater than 1? Of course, it is greater than 1. So this series, when the common ratio is greater than 1, greater than or equal to 1 in case, then the series sigma 3 power n is equal to 1 to infinity. This is a divergent series. This is divergent because the ratio is greater than 1. I'll give you some more examples. Some more examples of the series. Let us take sigma n is equal to 1 to infinity. Let us take 1 by 3 power n, let us say. Then what is this? This is 1 by 3 plus 1 by 3 square plus 1 by 3 cube and so on. Now, what is the common ratio here? It is with 1 by 3, if I multiply, I am getting the next term. So 1 by 3 is less than 1. Therefore, the series is convergent. The series is convergent. When it is convergent, when it is a geometric series, first of all, the geometric series only will have the common ratio. Understood? So this common ratio is less than 1 and is convergent, and it converges to which element? Converges to which point? The point is a over 1 minus r. What do you mean by a here? A is the first term of the series. A is the first term of the series and R is the common ratio. Now in the first term of the series is what? 1 by 3. So it is 1 by 3 over 1 minus of 1 by 3. What is this value? 1 by 3 over 2 by 3. And that gives you 1 by 3 multiplied by 3 by 2, and that gives you 1 by 2. So the whole series, that is the beauty of the series. Even though it is an infinite number, it is consisting of an infinite number of terms, and when you sum up all these, it cannot be infinity, it is going to 1 by 2. This is how it happened. I have explained in the previous lecture. Just go through that. And let us now have one more example as what is the convergent series. Let us say take this as 1 by 4 power n. By seeing the series itself, you can immediately say about the common ratio, and now you are able to write down the common ratio immediately. I can say it is 1 by 4, correct? And 1 by 4 is less than 1, and therefore the series is divergent. Sorry, the series is convergent. When the series is convergent, I can say about the when the series is convergent, then I can say that what is the limit of the series. What is the limit of the series? So what is that? It is a over 1 minus r. What is a here? My first term is 1 by 4 itself. 1 by 4 minus 1 by 4. 1 minus 1 by 4. That is 1 by 4 over 3 by 4, and that gives you 1 over 3. So it converges to this point and it is convergent. I hope you could understand. So let me take one more example and try to see this. Summation n is equal to 1 to infinity. I have 2 into, let us take 3 power n. 2 into 3 power n it is. So how will you rewrite this? This is 2 into 3 plus 2 into 3 powers 2 plus 2 into 3 cube and so on. So what is a here? A is 2 multiplied by 3, and what is r? R is 3 itself. R means the common ratio is 3 itself. So how you are getting? Now I am telling you one hint here. What is the hint to find out the common ratio? The common ratio you will get by just second term, whatever you have, that is the second term by the first term. If you do, then you will get the common ratio. So here the second term is 2 into 3 square. My first term is 2 into 2 and 2 into 3, and therefore 2 gets cancelled, 1 3 gets cancelled, the value is 3. So the common ratio is 3. And what is the common ratio? Is greater than 1. So what can you say about the series? Sigma 2 into 3 power n is a divergent series. Is divergent. I hope you are able to understand about the convergency and divergency of the geometric series. Thank you. I'll be explaining you about the power series in my next video.